Welcome to The Explainer, where we break down big topics. Today, we are diving deep into the fundamental laws that govern, well, pretty much everything: energy, heat, and chaos itself. We're talking about thermodynamics. You know, it seems like such a simple question, right? But the answer lies in a set of universal rules that dictate everything from your morning coffee to the ultimate fate of the stars. Okay, let's get into it. All right, before we can jump into the actual rules, we kind of need to learn the language. In thermodynamics, we don't look at the whole universe at once. We focus on one specific piece at a time. So first up, the thing we're actually studying is called the system. This could be anything, really. An engine, a chemical reaction, or, yep, that cup of tea on your desk. And everything else, literally, the rest of the universe that's interacting with our system, we just call that the surroundings. Simple as that. And the line that separates the two, whether it's a real wall or just an imaginary line we draw, that's the boundary. Seems pretty straightforward, but here's where it gets interesting, because how these boundaries behave is key. You see, systems can be open, closed, or isolated, and it all just depends on whether they let energy and matter cross that boundary. This little distinction is absolutely crucial for understanding the cosmic rules that are coming up next. All right, now that we've got the lingo down, let's get to the main event, the very heart of thermodynamics. And I gotta say, these aren't suggestions or guidelines. These are fundamental, unbreakable laws of the cosmos. Okay, rule number one. This is the big one, and you've probably heard of it. The first law of thermodynamics, and it's all about conservation. What it says is that you can't just create energy out of thin air, and you can't make it vanish into nothing. You can only change it from one form to another, like from the chemical energy in gasoline to the kinetic energy of a moving car. But the grand total amount of energy in the universe, it always stays exactly the same. So what's the bottom line? In the energy game, there is no such thing as a free lunch. You can't win. The absolute best you can ever do is break even. Now, the second law. This is where things get really, really profound. This law introduces a concept that tells us the direction that everything in nature has to go. And that concept is called entropy. Now, it sounds complicated, but really, it's just a fancy word for disorder or randomness. Think of it this way. A neat, tidy room has low entropy. A messy room? That's high entropy. And here's the law. The total entropy of the universe is always going up. Things don't naturally get tidier. They naturally get messier. They move from a state of order to a state of disorder. This right here, this is why your coffee always gets cold. The heat energy from your hot coffee naturally spreads out into the cooler air of the room. It increases the overall disorder of the universe. It will never, ever spontaneously gather itself back into your cup. So, if the first law says you can't win, the second law says you can't even break even. So now we have these two major cosmic rules. Can we actually use them to predict the future? Well, in a way, yeah, we can use them to predict whether a process is going to happen all by itself. In chemistry, we call that being spontaneous. Now, that doesn't mean it happens on a whim. It just means a process can happen without any continuous help or energy from the outside. And a big part of that is nature's preference for higher entropy, for more chaos. I mean, an egg can fall off the counter and scramble itself pretty easily, right? But you will never, ever see a scrambled egg magically unscramble itself back into a perfect egg. But it turns out it's not just about chaos. It's actually a balancing act. On one side of the scale, you have the tendency for things to release energy. On the other side, you have that unstoppable drive towards more disorder. And scientists came up with this amazing tool to figure out that balance. It's called Gibbs free energy. Think of it like a final calculation. It takes the change in a system's energy and its change in disorder, puts them together, and spits out a simple yes or no. If that final value is negative, the process is spontaneous. It's nature giving it the green light. Okay, stick with me here, because all of this leads to a conclusion that is genuinely mind-bending. This constant, unstoppable march towards more and more disorder has a profound implication for how we even perceive reality. It's what gives time its direction. Seriously, most laws of physics would work just fine if you played the movie backwards, but not the second law. We experience time as a one-way street, an arrow pointing forward, because that is the only direction in which total entropy, total disorder increases. It's the reason we can remember the past, a more orderly state, but not the future. And that leaves us with one final and pretty provocative thought, something to chew on. Thank you for joining this explainer.